All right, so today we're going to talk a little about domain and range. And 2.1 we talked about input and output. And if you take a look at all of your input values, we call that the domain. And if you look at all of your possible output values, we call that the range. Another way of thinking about it in terms of a graph is that your x values that you put in, all the possible x values are called your domain, and all your possible y values are considered your range. If you actually look at this, each one of these are in alphabetical order, right? Input comes before output, domain comes before range, and x comes before y, right? So if you need a little like device to remember, that's a helpful way of remembering. And you've done domain and range in Algebra 2 before. This is true, right? So you may very well, remember notation that maybe looks like the domain is like -1 less than x less than or equal to 5. Does that look familiar? Okay. And you might have, some range value, I don't know what. Have you ever done like all reals y can't be equal to 0 or something like that? Right. Okay. So I have some imaginary function where that's the domain and range. I don't know what that function is, but I'm making that up. Is that okay with you? You don't have to, but you should know that there's another way of notating this. It's called interval notation. Did we talk about this yet? No. Instead of saying less than, you can use a parenthesis. I thought we did. And you can use a bracket, right? So that's one way of saying the same thing, right? Yeah. Now we did say that there could be confusion. If, suppose, like the domain was 1 to 20, the confusion could stem from the fact that someone might think that's a coordinate, a point. All right, so that can get in the way sometimes. If we wanted to say all reals y can't be equal to 0, I might say -infinity to 0 together with or union, right? Have you ever used that one before? Union, U, means together with 0 to infinity. So that says, look, it's -infinity up to 0, don't include 0, and then 0, don't include it, up to infinity. Do you have to use interval notation? No, not at all. You can use Algebra 2 notation. That's totally fine. And the book may use both of these notations. I might use both of them. The important thing is that you know what it means when someone else says it. Okay? But you don't have to use it. It's not necessary. Just a different way of saying something. Is that okay? You want to ask a question about interval notation? Okie doke. So let's take a look maybe at a problem or two dealing with domain and range. I thought we were going to look at a problem or two. There we go. Maybe we can look at 6. Actually, you know what? I think this is going to be easier. I think if we look at 7, you're going to find that easier. Maybe. I could be wrong. You'll tell me. All right, so sometimes looking at a graph can be really helpful when you're trying to determine the domain and range. Sometimes looking at an equation can be really helpful. Sometimes you have to look at both. Sometimes you're only given one and you can't look at it. So for example, here it is, I'm giving you a function, but I have no idea what the equation of that function is. So I don't have the algebraic function, I have to look at the graph. So it says this, each function is shown graphically has a domain of -6 to 6. So they're telling you the x values that we're putting in. And they do it in interval notation, right? Find the range, the zeros, and f of -2 for each of these. So let's start with the first one. I guess it's not really marked. I'll call it A. And give me one of the pieces that you would like to do. Elizabeth, what do you want to start with? A what? What point? I want to know, give me the range zeros or f of negative 2. You can pick one of those.
Okay, I'll take the zeros.
Okay, so where are the zeros? Alright, so Raphael's selling like... Okay. Go the other way, Raphaela. Like negative 3 point... Maybe negative 3 and a little. Say again? If you want, like if it's bothering you, you totally can. Okay. I would say about negative 3.1.
And about negative 4.9, maybe 5.
Here?
No, on the y-axis.
Okay. So when we say zeros, we don't actually mean when y is equal to 0. We're talking specifically when x is equal to 0. Okay, so zeros are just the x ones. Say again?
Y is equal to 0 when x is equal to negative 3.
I agree.
So, did you just say it was the other way around?
Did I say that backward? No.
You said all we cared about was when x was equal to 0.
I totally said that wrong. I'm sorry.
So all we care about is when y is equal to 0.
Yeah. We want to know the x values when y is 0. That's what a 0 is. The x values that produces 0 of the function. I apologize if I said that backwards. All right. Elizabeth calling someone to give us another piece. You have Danny and Evan. You have Monty in front. You got plenty of support here.
I like Danny better.
No. That's not what this is.
I mean, not better.
All right. Go ahead. Danny, tell us. All right. F of negative 2 is? Agreed? Is that the y? Is that the output when you put negative 2 in? All right, Danny calling someone for the range. Now we're down to it. We need to figure out the range of this.
Your range.
Yes.
I have this for you.
Oh, great. Thanks.
Check for $1 million.
All right, go ahead.
I think -5 and -3.
All right, so if we want to say the range, I agree with you. We can.
5 is less than y or less than 3.
Okay, so you can say -5 is less than y is less than 3. Rafaela?
You put in the bracket 3, -5.
You can. You can use interval notation. Now, the thing with interval notation, you always, when you use interval notation, you always want to start with the smallest value and go up to the highest value. So instead of doing 3, -5, we would do -5, 3. Okay? So Raphael is saying, look, in interval notation, it's this. What do you want to say?
I want to say that I feel like we should include 3, not less than 3.
So Elizabeth is saying it's debatable. You could actually do less than or equal to and put a bracket here. And you could probably do the same with -5. It's a debate.
If they did it for -66, then they could do.
Since it's just a graph, we really would have a hard time telling. Does that really go to 3? Is it just below it, just above it? So you could actually be right by using a bracket or a parenthesis.
So you want to test like either way.
Exactly. In this case, because it's a graph, we lack the precision. Now, if I gave you the function, then algebraically you could actually tell me what it is. Okay, so there's a difference depending on how the question's posed, how accurately you can answer. Let's try one more. Hey, Max, what do you want to try for B? Do you want to do range, zeros, or f of -2?
I'll do
All right, when you put -2 in for the input, what do you get out?
actually don't. Oh no, wait.
All right, so Tom, why don't you take this one, and then Max, you can choose another one.
0?
Yeah, when you plug -2 in, you get 0 out. So Max, do you want the easy one or the hard one? All right, so we can do the zeros easy because Tom actually gave us gave us our answer. Where do zeros happen? Where? Say again? Yep, at x equals -2. Okay, so Tom and Max actually gave us the same answer. All right. All right. Range. We need to be careful. Tom, who's up?
Gavin wants to.
Okay. I know this is like a borderline trick question. So is it like...
You know me too well.
Is it like... Wait. It would be negative... greater than... negative 5. No, wait. It should be like greater than or equal to negative... No, wait. Greater than... greater than negative 5, y less than 3.
That class has way too much loud
All right, so
They heard me.
got a question. I think Evan has the big picture, but Jen, do you see like a little? Can we do a little nitpicking here? Because yeah. So actually, what y values does it not include?
From 1 to 3.
Okay, so Jennifer, so negative 5 up to what?
1.
Does it include 1?
Yeah.
Okay, so let's do that. Okay. So that's part of it. And then Jennifer suggested maybe we do like a union or together with what?
3.
All right. Y is equal to 3. Now, someone's going to argue, but wait, there's an open circle here. It doesn't include 3. Right? No, can you see someone's going to argue that?
I didn't know that it meant.
It does, but no, don't erase. Because you know what my argument back is going to be? Yeah, exactly. But look, it does include 3 in all these places. So just because it doesn't include 3 in one spot doesn't mean it doesn't include 3 at all. Okay? So this is sort of funny notation. It's like cobbled together a couple different pieces. But
Y is less than or equal to 3.
no, y equals 3. It is equal to 3. Okay? Right along here, that's y equals 3. Okay? It's y is equal to that value. All right, soccer players, do well, score 1 for me. We're probably going to do a little bit of algebraic work, so you're going to want to check out the screencast. All right? All right. Yeah, nice work. All right.
Sorry.
No, go ahead. Do well. Make us proud. All right. Let's talk about domain and range with an algebraic function. All right. Hey, Monty. For A, this domain, we could graph it. You could actually graph it and ask yourself the same questions, but I actually think you can look at it and tell me, where are we going to have problems? What x values are going to be problematic here?
3.
Try again. No, definitely not.
2.
Yeah, without a doubt. What happens when we try plugging 2 in?
Equals 0.
Yeah, the denominator is 0 and that's a problem. So we would actually say, for this, the domain is all real numbers except x can't equal 0. Or, well, so go ahead.
For the symbol for all real numbers, is that fancy R?
Yep,
I just wanted to...
you could do that. Like that, sort of like a cursive R.
Well, R with the extra. Like an IR when you wrote it.
Oh, he did, okay. So you can either do the script R or he did like the double.
Yeah.
That's the one. It's been so long since I've
I love it. Okay, you could also say negative infinity to 0, union with 0 to infinity. That says the same thing. That's fine. Mo. You're absolutely right, Mo. After Monty gave us that nice right answer, you couldn't be more right and I couldn't have been more wrong. Maureen points out that we had agreed upon 2 being the problem, not 0. I apologize. I'm sorry. All right. Now, here's the thing. The domain is usually easy to look at the function until the range is actually pretty hard to look at algebraically what sort of values you're going to get out. It's easy to say, oh, I can't put that in or I'll have problems. Like if you see like a square root sign, immediately what sort of things bother you when you're... Denominator is fine. What'd you say, Sam? Did you say something? Odds is fine. Fractions.
Partial? You can have a fraction.
Negative. You can't have negative square root, right? So negatives in the square root would bother you. So if like x was like 3, can you see 3 minus...
have a square root in the denominator.
You can have square roots in the denominator. Your algebra 2...
We just
Your,
enjoy them.
your algebra 2 teacher might like you to simplify it, but there's nothing wrong with a square root in the denominator. Wait. My point being this, though. You can look at functions and very often tell what the domain is going to be, just looking at the rule. The range is very, very hard to look at it and be able to tell. As a matter of fact, 9 times out of 10, you really need to have a picture, either in your mind or on your calculator, about the range. So, for example, I know that 1 over x minus 2 is going to have a vertical asymptote of 2, and the function is going to look something like this. All right? And if you look at that function, if you scan up and down the y-axis, you should ask yourself, is there any y value that this function is never equal to? Are there any like gaps or holes for y values? And your answer should be yes.
Oh, is it 2?
Actually, 2 is where we have a problem with our x values. That's when we go this way.
The y is the...
When we go up and down.
Is that the horizontal axis?
It's like
Yeah.
It should be 0.
Wait, this is good, right? Yeah, no? Say again, Sam?
Shouldn't it be 0?
Yeah. We have a problem right here. The y value is never equal to 0. There's nothing you can do. Go ahead, try to solve this equation.
okay, 1 equals x minus 2. Oh, oops.
1 equals,
0.
that's a problem, right? Now, would you have guessed that just by looking at the function? Probably not. Or sorry, looking at the rule. But you get a better idea when you look at the function. Sometimes looking at a table can be helpful as well.
So
All right.
y is greater than 0.
So I would say y can't be equal to 0. And maybe, Maureen, this is what I was trying to say. I was trying to say the y value. I'm joking. I had no idea. But I thought that was a pretty good recovery on my part. Is that all right? Let me quickly talk about C, and then maybe we can take a look at one of those homework problems that we haven't gotten to. For C, we have the absolute value function. And if you have quickly in your mind what the absolute value function is, finding the domain and range becomes a little easier. Do you remember absolute value function?
No, it's a V.
V, okay. Absolute value function looks like this. So if I ask you the domain, that means going along the x-axis, can I put all x values in?
Or yes.
Yeah, I can put anything into that rule. So we would say all reals, or negative infinity to infinity. The range of this function, you look along the y-axis, and you ask yourself, are there any y values that I don't get as outputs? And as a matter of fact, there are. There are lots of them.
Should be all positive. Y is greater than.
Okay, so the range is going to be everything that's positive or greater than or equal to 0. I can't get negative y values out. Why? Well, it's the absolute value function. It always gives us positive values out. So we would say that the range for here, you could either say is 0 to infinity, or what did you guys just say? 0 less than or equal to y. No, how'd you? Oh, that you would have just said that y is greater than or equal to 0, right? That says that. All right. So can you see that graphs are important and rules are important, and sometimes you need them both? Say yes. Okay. All right. Yeah. Let me turn this off, and then Corinne